Experimenting this morning. Hey, guys.
Hello. Experimenting with Doug Borszynski from the Buffalo Museum of Science. What have we got going on here, Doug?
We're going to do some experiments with water. Earlier I was dropping some drops of water on a penny, and water is unique because it has positive and negative charge. It's bipolar, so it kind of sticks together. On the penny, it's big. It made this big wall. You can actually guess how many drops can fit on a penny.
I don't know, like...
I can do 40.
You can do 40 drops?
Yeah.
I was going to say 5. I was off by a lot.
But here, I got some water here, and what we're going to do is put this little boat in here.
Okay.
And normally in the water, it's going to kind of go towards the middle. Now, what I want you to do is we're going to break the surface tension with soap.
Okay.
So pick up your swab.
Swab.
And you're just going to hit just a little bit of soap.
And is this just regular dish
Yep, this is just
soap? How much do I need?
Just a little.
Like
now
that?
you're going to put it right behind the boat and watch what happens.
Okay, like here?
Yeah.
Oh, man, the boat's moving!
I love this in my bathtub, personally, as a way to get the water more soapy. Now, if you do it a couple more times, you'll eventually realize that the soap, is actually going to make a really tiny film, and it'll stop working. You try it probably one more time.
One more time? It
but
will work
once that soap completely disperses over the surface...
It's not working.
Nope, that's what happens.
Oh, did I put too much soap on it the first time?
It doesn't take much. But
That's
just
very
enough, it makes a little tiny film on the top, it breaks the surface tension, and now our boat's stuck.
Now, if we were to talk about this on a real-life scale, how big of a swab and how much soap would you need to power a boat?
I don't think you want that much soap in the lake.
Oh, well, who says we're doing it in the lake? Maybe a pool?
A pool, oh. You know, I've never tried that.
So what is it about breaking the surface tension that makes the boat go forward? As
the surface tension is breaking behind it, it's actually pushing the water and making this bigger circle, and it's just riding the outside of the wave. As that surface tension is breaking, it's just going with the water. As the water's going away, and you'll see that in our second experiment a little bit later.
Yes. Now, what can kids learn from this experiment? Because I learned, you know, wow, this is cool. I made a boat move with soap.
Water is a universal solvent. Because it's bipolar, it can break apart stuff. There's negative charge, positive charge. It's playing with water. It's the way it sticks together. It's the way capillary action works, because the water sticks together and draws up. It's the way that trees actually get water through transpiration, because that water sticks to each other, then evaporates through the leaves. So the idea of water, it's just amazing the way our planet's formed just because of water.
It absolutely is. We're going to be back with Doug later in the show to do another experiment. We talked about it a little bit, but for now, we're going to go back to Joe and Victoria.
I love that. I'm going to do that with my son when I get home.
Hours of energy.